Discourse Analysis and Technology in STEM Classrooms invites veteran and service teachers to consider emerging from their content silos to advance their instruction through the synthesis and integration of science, technology, engineering, and mathematics. The roles and values of STEM are interdisciplinary and multidisciplinary instructional foundations that can transform teaching and learning in today's classrooms.
The important piece about STEM, more than anything else, is thinking in an interdisciplinary and multidisciplinary way. How science informs math, how math informs technology, and where they touch, if you will, and how to take those overlaps and be able to use them in a classroom situation, be able to explain how they actually connect and interact.
When teachers connect these disciplines and focus on project-based learning, students are better able to understand STEM lessons. One of the easiest ways to involve the students is through gameplay.
So we know the distance falling, now we're kind of working backwards to get the rubber band. See how we started out with the rubber bands checking the distance? Now we're flipping it. If you're constantly just saying, okay, solve this problem, you know, eventually they may get it. But when you're doing an activity like this and they have a beginning, a middle, and an end, and they're seeing it in practice, and that really stays with them.
Where this lesson is going today is really thinking about changing the outer, changing the inner.
So this class builds on the first class for all the MED students in STEM education, where you take your practice and this game that you've created, and you now get to implement it and look at what that looks like in a classroom.
By looking at the interactions between the STEM fields and the lesson plans enacted by the teachers, data can be gathered about the effectiveness of the lesson.
My STEM project is designed to teach a standard unit of circles in geometry, but in a more appealing, more engaging type of way. And what I've done is I've presented the students with this remote control car that has a broken wheel. Using math, using formulas for circles, they need to find the actual units of measure of another wheel on the car, and they need to replicate it. And they walk away knowing that from start to finish, they've been able to use mathematical formulas. They've been able to use context clues embedded in codes to decipher and find out the right information that they're going to need. And they're able to not just stop there, but actually print out something using technology that they can take home, show their parents, or actually use it on a car.
Discourse is any written or spoken communication. This course focuses on the analysis of the discourse within the classroom by posing the questions, what are the students talking about, and are they communicating about the disciplines?
This program is going to require you to delve deeply into what actually goes on in your classroom. We've really focused on discourse because that's what happens in real classrooms. What we've done in this course is we've broken it down by each of the STEM disciplines, and we focus on the discourse as it relates to science, technology, engineering, and mathematics, and we really focus on it all in each of the units. And then in the 5th unit, we put it all together so that these teacher candidates can actually integrate their teaching.
This course promotes STEM as a tightly braided strand of disciplines that can be mutually reinforcing and preparing students to think across content areas and develop a kind of intellectual agility that our students will need as they learn, work, and play.
I think the biggest thing that they're going to learn is that math is not a separate entity from science or technology or engineering. They all rely on each other.
Okay, so what happened?
It hit the ground.
Hit the ground, but the last time it was a little bit less, right? So, what do you think?
Take about 1 or 2 bands off.
Okay.
STEM is important in everyday life, and it limits the questions of when are we going to ever use this?
And many of our students nowadays in K-12 environments are very tech savvy, so they know that sometimes better than the adults. Well, what we want to do is to take advantage of that. In other words, use that as a kind of a Trojan horse to actually allow students to understand science, understand engineering, and understand mathematics, because they do have some knowledge of the technology, and just pull them through and to get them to see those different pieces.
In this course, candidates will conduct inventories of their STEM content knowledge, defining teaching from interdisciplinary and multidisciplinary perspectives. Develop an understanding of teaching and learning STEM through inquiry-based instructional methods. Learn how to frame STEM content areas while recognizing the importance of data collection and evidence-based outcomes. And advocate for lifelong, life-wide, and life-deep professional learning.
Science is a process, a way of learning, a way of knowing, and so kids need to do science to learn science.
STEM is something that really needs what people term hands-on involvement. That's what we're looking for, and we hope to encourage candidates to do more of that hands-on work outside their discipline as well as within it. So we hope that we'll be able to break those silos. Students need to see themselves as scientists, technologists, engineers, and mathematicians, but in order to see themselves doing that, they must see the teacher doing it too. And so by being a model, a role model in some sense, in the physical sense as well as in the intellectual sense, we know that students will get that vision, and we hope that our teachers will adopt some of those personas and roles as they go back into the classrooms.